with microcontrollers. You know, those BTech days where you curse your lab instructors and Viva instructors, right? But guess what? They are back. They're back to bite us. We have to deal with microcontrollers going forward. One side we have microcontrollers, on the other side we have microservices, right? That's another buzzword. So when you connect microcontrollers with microservices, a lot of interesting things happen, right? And that's primarily internet. Find the magic quadrant of a technology, right? And guess what? IoT banners are showing up in Amirpet. That means they're really trending, right? So, so microcontrollers and IoT are definitely the future. But I haven't answered why they are so hot at this point when microcontrollers have been around for such a long time, right? So the deal is this. Earlier microcontrollers remained completely disconnected and they were not talking to each other. But in the current context, now thanks to ubiquitous connectivity, which I don't believe in because we are struggling for connectivity. I don't think there is anything called ubiquitous connectivity, but in certain geographies and certain parts of the world, connectivity is ubiquitous, right? And there is another emerging technology that really connected the dots, and that emerging technology is cloud, which we didn't have a few years ago. And then there is one more trend that has revolutionized, which is big data and analytics. So when devices start to talk to each other and they are connected to each other via the cloud, and we are able to capture the data streams that are generated by these devices and apply our upcoming latest technologies like machine learning, predictive analysis, and big data, we tend to see a lot of interesting things, right? And that's what is driving this whole momentum around Internet of Things. I'll give you a very simple example. I'm dependent on an app called Runkeeper, right, which runs in my Android phone, on my iOS, and any device that I use, right? So Runkeeper basically is a pedometer, and it is also tracking your activity, physical activity, which is like Fitbit or Jawbone or Nike Plus or a lot of those devices. Now, interestingly, I'm able to capture a lot of stats about my physical activity, which is pretty good. But that data is still contained within my mobile, right? Let's say my doctor, my family doctor is interested in understanding my lifestyle and my physical activity because he is tracking my blood pressure and my potential diabetic attack or because I'm prone to that because my parents are diabetic. So I get some warning signals, warning signs from my family doctor saying I should be doing something. Now, imagine the doctor, the family doctor, is able to track your Runkeeper activity on his device. So if you haven't walked or biked or ran for 5 days, your family doctor gets to know it and you get a WhatsApp message from him, right? Because Runkeeper hasn't talked to him for a while. Actually, not him, but his app, which is tracking his regular patients, right? So this is basically making machines talking to each other. And how are they connected? This data is actually being stored on the cloud. And when the threshold is met, either lower or higher, there is an alert that goes to certain subscribers. Wow, okay, this is up and running, fantastic. So this is going to be extremely challenging, but let me see how far we can go with this. Okay, so now the three things that are basically driving the IoT momentum and the IoT revolution: sensors and actuators, right? For a long time, we have been surrounded by sensors. We never realized it. For example, when you get into a lift, an elevator, and you try to get into the elevator and the door just comes very close, but then it automatically goes away. You know there is a sensor acting there. An ultrasonic sensor that detects the movement between two doors. And when you interrupt the ultrasonic wave, it sends a signal that something is interrupting, which is in between, and it's going to go away, right, without really locking it down. Similarly, certain car windows, right, when you are doing automatic close down or shutdown of windows, or when you are dealing with the doors, when there is an object that is kind of blocking, it automatically stops that process before it hurts anyone. So all these are all actually sensors, right? We are dealing with a lot of sensors. But those sensors are now connected with each other. And that data is being harnessed for a lot of intelligence. That is one. The second one is connectivity, which is debatable, but connectivity is driving this. And ultimately, people and processes, right? When you bring all of them together, we have pretty interesting scenarios, and that's what is called Internet of Things. So I'll be very brief. So sensors and actuators, basically as humans, we have certain sensors, right? We can touch, we can feel, we can taste, we can smell. There are sensors for all of those. And when you put all of them together, a lot of interesting things happen. And then there is connectivity. Connectivity from power on Ethernet, it's called PoE, to all the way up to some of the emerging protocols like MQTT, CoAP, PubSub, right? So this entire spectrum where devices are connected and machines are connected, that is actually driving this new trend of IoT. So it's connectivity. And finally, people and processes, right? Customer relationship and support. So it starts from very fundamental things. Like in Amazon.com, if you add something to your shopping cart and don't check out, Amazon will send you an alert saying, looks like you're interested and here is 10% discount, right? That is very typical CRM. But imagine going to a store, going to a mall, a physical store, you pick up a dress, you flip it around, you look at it, and you feel it's too pricey, you drop it and come back. And then you get a call saying, looks like you're interested, come back and we'll give you a better discount, right? That is next-gen CRM, right? Because you are actually wearing a royalty card that a lot of these multi-branded chains give you, that has an RFID tag. And when you are walking around in the mall, and when you are stopping at an Arrow or a Van Heusen, and you are looking at the shirts, it basically tracks that so-and-so customer was holding this shirt but didn't buy it, right? Your royalty card spoke to the shirt that you were interested in, and they did a handshake, and that data is recorded, and that goes into the CRM. And it is not fictitious. That happens today, right? It can pretty much happen. So that defines the next-gen CRM. That's one example of how people, processes can be a part of the IoT. So these converge into certain interesting things like, intelligent smart thermostats, smart cars, self-driven cars coming from Google, and Tesla 3, which is again a very innovative, very unique automobile in US. Activity trackers like Pebble and various wearables that we are dealing with. Smart switches. So the Belkin switch is actually a Wi-Fi enabled switch. So you can basically remove your existing legacy plug points and replace them with Belkin plug points, and suddenly you have an app. So sitting in the TV room, you can operate a switch in your bedroom or drawing room or kitchen, because every plug point now becomes an access point, right? So those are some of the scenarios. So that leads to much more effective verticalized industry solutions like consumer, mobility, healthcare, infrastructure, manufacturing, B2C, which is like, it is G2C, government to citizen, smart cities. I'm from Andhra, so Chandrababu Naidu is now talking about smart cities, and he's getting a lot of delegates from Singapore and Japan. So we are eagerly waiting how smart Andhra will become, right? So all of them are actually converging into that. But we are developers, right? How do I get started? All of these things look very, very rosy, very flowery, very exciting, but I'm a developer, right? Show me some code. Let me get started. How can I claim that I know IoT, and how can I update my resume with IoT? That's what we are interested in, right? So that's my point, right? I'm going to really tell you how you can get started with IoT. So can I have the cam? So I have some very different gadgets here, right? So let me walk you through them. So I'm going to open up certain things. So How many of you are familiar with this board that's called Arduino? Okay, very few. 6, 7? Okay. So this is actually a microcontroller, right? And this microcontroller is very powerful. Though this board looks pretty big, the brain of this board is just one IC, one integrated circuit. So you can use this as a prototyping board, and you can program this using your familiar C language. And once you program, you can pretty much pull out the microcontroller and embed that in very tiny devices. So don't think this board is really big and how you can build smart switches and smart microwave ovens with it. This is meant for prototyping and developers. And this is actually called Arduino Uno 3, right? It comes with very basic, I have some stats here, it comes with very basic flash, 16 KB of flash, 1 KB of RAM, 14 digital I/O pins, right? There are pins that you can actually see, and these pins will let you connect to switches, actuators, and sensors. So this is how you will actually start doing a hello world on IoT, right? So what IoT is basically, from a development standpoint, there are two things. One, how can you read data from physical objects, and how can you control physical objects through software, right? It's a lot to do with read and write. For example, you are switching on and off through software, through cloud, through mobile. That is writing. You are writing some values to this microcontroller, and it operates a switch. It is basically bit manipulation, nothing else, right? Sometimes you want to read. For example, you put an ultrasonic motion sensor and you attach a camera. When someone moves around, the camera captures an image, uploads that to your Dropbox. You are reading, right? So this becomes your conduit to dealing with physical objects. That's what this microcontroller is all about, right? And this comes with a USB port. So this is the old USB cable that we are very familiar with. So we hook up the USB port and then power it, right? So I'm going to connect this to Mac. So now you'll see a small bulb glowing, right? That's an indication that this is drawing power, and now I can get started with programming. This is very, very raw, as in, if you are familiar with electronics, I have to bring a breadboard, I have to bring jumpers, I have to bring sensors, and I can keep doing this till next Azure conference. That's going to be very, very painful. So technology is very, very rapid. So while Arduino was manufactured in Italy by a professor, this is like bare metal infrastructure, right? This is the microcontroller. And attaching sensors to this is going to be painful. So there is another company in China called Seed Studio. And what they have done is they created another layer which looks like this. And this is actually called a shield, right? Which will make it easy for you to deal with the microcontroller. So this is infrastructure as a service. This is platform as a service, right? Because I'll never have to deal with the core VMs. So I'm going to hook this up. So it's going to be pretty straightforward. This will make it easy for me to plug in sensors and plug in switches. So I'm going to just hook it up. And this instantly gives me plug and play capability. So I'm a developer, I don't want to spin up VMs, I want to git push, right? So this layer gives me git push capabilities. So now we have our basic environment ready, but now it's time to really put some sensors and actuators and stuff, right? So that's where I'm going to pull up my other small widget, right? This is actually called as a Groove LED connector. So I'm going to use the familiar light emitting diodes. So I'm going to plug them into this. I have to be careful about the polarity. So now I have very basic LED widget, and I'm going to hook up another, right? We have issues demoing software. Imagine the plight of demoing hardware. Anything can go wrong, right? One small reversal of anode cathode can create a havoc to your demo. So you have to be extremely careful. Okay, so now we have two LEDs and I'm going to plug them into these sockets, right? So this makes it easy for me. So the red LED goes to digital IO pin 2. So I'm going to hook them, right? Oh, cool. Okay. So that is one, and then I'm going to hook up another LED, right? Now we have very basic circuit, a microcontroller with two bulbs. And what I want to do is to really write code to control them. You'll see one bulb is already blinking, right? Now let's actually write code to blink both alternatively, like disco lights, right? Which Mithun Chakravarti used to popularize in 80s. So we'll create that. And don't think this is IoT. This is hello world of IoT. Okay, so can we switch to the machine, please? Fantastic. Okay, so a little bit more on Arduino board. So this is how it looks like. So you have a USB power socket. By the way, you can also power up using the 9-volt cell. And there are some pins. Can you be here? I'm going to switch again. Yeah. So we have to be very fast. So those are the pins where we are going to hook up the sensors, right? So there is a PC for programming. There is Arduino for save your code, and that's going to control a bunch of sensors, right? So let's say hello to things. Okay, let me jump to the demo. So how do I get started? How do I program this simple thing, right? So I'm going to launch an IDE, right? It's called an integrated development environment, and this is designed exclusively for microcontrollers and for Arduino. So I'm going to write a C program to control this. So to save time, I've already, but basically let me show you. So when you are writing code to control this is going to be very simple. There are only two functions that you need to worry about. So when you are programming microcontrollers, you will have to just write two functions. One is called setup, right? This is where you will do init. This is like the constructor. This is where you will define where the pins are actually listening, right? Whether you are doing an input or output, what are the pins that you are dealing with. For example, our blinking LED is already connected to pin number 2. So I would define those in setup. Then there is one more function that you need to be familiar with that's called loop. And this is where you will write code to read the sensors or to write to the actuators and switches, right? So that's the fundamental, the basics of programming Arduino. So let me, unfortunately, I can't change the font size of Arduino. So I'm going to copy and paste it and walk you through it. So let me open demo 1, okay, which will create our disco lights. So this is the program, right? So now I'm connecting two bulbs to pin 2 and 3, right? Microcontroller pin 2 and 3. And I'm designating that as output. That means I'm going to write, okay? That's what is, think of this as a constructor. The setup happens there, right? That is the init function. And then there is loop. So here I'm saying write to bulb 2 and the value is 1. And because we are doing a digital write, you can only write 1 or 0. So we are sending 1, that means whatever bulb is attached to 2 will glow, and we are switching off whatever is attached to pin 3. Okay, and we are going to wait for 1 second, delay 1000 milliseconds, and then I'm going to reverse it. I'm going to make pin 3 1 and pin 2 0. Very simple, right? So let me come back to my Arduino IDE, and here this is, by the way, called a sketch, right? It's called a sketch. So I can program multiple boards, but currently I've selected Arduino Uno, and it is connected to my USB port, so I'll choose that. And here, if I push this is going to burn this code into the microcontroller, right? So now, okay, can we have the camera? I don't think we need camera. You can see this, right? The disco lights are working, okay? So this is very, very simple hello world. Actually, this is better than hello world. In IoT terms, hello world is blink, which we have already seen. But this is slightly an improvised version of hello world. Okay? So, are you with me? Yes. Fantastic. So this is how we actually write to Arduino. Now, what is the thing in it, right? How can I control? For example, we are in a very strict office environment, and we are working on extremely tight deadlines, and this is World Cup season, and your HR has worked with IT to block every possible portal that shows live score. I don't know how you work there, but I can't, right? And for some reason, because of the CC cameras and the compliance and various things, you are not allowed to carry your devices, right? This works. This happens in a lot of environments, right? HIPAA compliance. There are CC cameras, and you are supposed to surrender your devices. Now, you want to sneak in something, very simple thing. This is my small little thing that sits in the corner. Everyone thinks it is a broken keyboard. No one understands microcontroller and IoT and all of that. But I want one simple thing. Every time Bangladesh loses a wicket, I want the green bulb to blink. Right? And I'll feel psychologically happy that a wicket has fallen. Now we are talking about things talking to each other, right? So I will program this at home. I will, there is an official ICC Twitter feed, okay? I use Twitter API to read the live score, and every time the Bangladesh wicket falls, I will program this to blink, okay? Now we are making things work. But how does that work? So now it's going to be slightly interesting. I'm going to launch my second demo, okay? So you can actually control this interactively. So now I am actually launching, this is absolutely unreadable, don't worry, but what I have done is I have simply put an if condition, right? And this if condition takes red or green and glows that bulb. Very simple, right? But where does this input come from? It comes from the serial port. Remember, this is connected to a serial port. So if you are still familiar and remember RS-232 communications, right? How you can write to serial port. This is exactly the same. So now let's keep this as it is, okay? And I'm going to push this code into my microcontroller. So both the bulbs go off, because now I want to control them. I don't want them to alternate, but I want to control them. So I'm going to leave this as it is and bring up what is called as a serial monitor. So here you will see that's the monitor, and I'm going to launch my command prompt. And from here, I can basically interactively control this, right? So Raj, can you just hold this? Okay, so, oops, watch out. Okay, so, not it. So cd IoT Azure conf demo 2, okay? I have a very simple program. So, and this is a Python program. So I'm going to say Python led.py red, okay? And red glows up. Are you able to see? Okay. Now I'm going to type green, and green comes up. That means we are able to control this interactively. The next thing is hook up Twitter API, and you have an IoT project, right? That's not all. This is still not a thing. What I want to do now, okay, I feel like a magician, right? Bringing up more rabbits out of the hat. Okay, so now this is nothing great. It's connected to the USB. Everything is very, very tightly wired. But how about this? This is an iPad that I am holding. This is a thing, and that is a thing, okay? And I want this thing to control that thing over the cloud, okay? So let me, unfortunately, I can't show you what is going on in this, but I'm going to do something that will control it, okay? So you have to trust me on this. And I'll tell you, I'll walk you through what I have done here. Okay, so now it is green. My iPad is going to control it and turn that into red. Okay, it's got to be red. Yeah, okay, that is red. Now I'm going to control and bring up green. Okay, so now let me execute. Okay, that's green. Okay, now please don't mind, I'll take the questions later, okay, because this flow is very important for me and I have very little time. So now we have gone from blinking a very normal LED that our kids have fun with to making things talk to each other, right? This is a thing, that's a thing. And how are they talking? This is where it gets pretty interesting. You know what I have done? Though this looks very trivial, this iPad is talking to that over Azure Service Bus. How many of you are familiar with Azure Service Bus? Great. You know the technology that's connecting? This is basically Azure Service Bus queues, or even I could use PubSub, right? So when I send a message from this, I send what color I want as a packet, as a message in the queue, and I have a listener sitting on my machine that is grabbing that message from the queue and controls it. Okay? Now we have gone from basic physical object getting controlled by software to controlling it over the cloud. Now nothing prevents me from hooking up Twitter instead of iPad. So Twitter feed will send a message to the message queue and this guy will listen for that, and every time there is an event, it just triggers. By the way, I didn't want to carry it because I've been flying from Hong Kong and I didn't want people to look at me as a bomb assembler. But I actually wanted to carry physical bulbs and put 100-watt bulbs that you can control from the same architecture. Nothing changes. The beauty is, if you're able to control those tiny little things, you can control this entire wiring. You can pretty much control this entire hotel with the same microcontroller. That's the beauty, that's the power of it, right? Okay, so that is done, right? This is one way where we are writing into the microcontroller. Now we'll make it, thanks. You have been like a statue. Awesome. Okay, so now we are going to turn this into slightly more interesting, right? And this will show you something more real world. And again, I can do a lot of things, but I'm going to keep this simple. So we are going to capture the humidity and temperature in this room and monitor it in real time, right? I want to do two things. One, I want to monitor it in real time. Second, I want to get historical analysis. I'll give you a better use case of this. Let's say the combination of this parameter, the pressure and the temperature, can be fatal if they are not tracked properly. If the fatal combination of pressure and temperature meet, that can potentially explode the whole manufacturing plant. So we want to build an intelligent system that tracks for that unique, dangerous combination of pressure and temperature in real time, and when the threshold, if at all met, immediately that unit responsible for filling up that gas cylinder will be shut down immediately, and an alert goes to the floor manager, right, in real time. And then after that is done, I want to go back and look at last 3 months of data, whether this was malfunctioning, which we have already missed. So I need historical data, right? So it is not just real time. We need historical data. We also need to do some proactive, reactive stuff as it happens, right? So that's a scenario that I want to show you. So for that, I have another sensor. I think now I don't need a camera because you are familiar with it. So I have a fairly sophisticated sensor which actually tracks the humidity and temperature. Very tiny, very small sensor, okay? And I'm going to hook this up. I'm going to get rid of these bulbs. So we are moving away from Hello World to slightly more realistic example. So I'm going to hook this up to one of the other analog pins of my microcontroller. So now we have the sensor hooked up, and now we are going to read. Earlier we have written to the LEDs, now we are reading from the sensor. So we'll leave this as it is, and let me open up the sketch that's responsible for reading the sensor data. Okay, so this code is slightly lengthy, but again not so difficult to understand. So this is C. So I have included some header files. DHT stands for humidity and temperature, right? So I am listening on A0, that is the analog pin 0, and this comes with a library that gives me lot of helper functions. So now I can define a float for humidity, float for temperature. I can read temperature, and I'll do some basic validation and print an error. Otherwise, I'll actually print the value of H and T separated by a comma. So if this program runs successful, and I don't want to overwhelm the sensor, so I'll delay for about 800 milliseconds. Are you with me? It's pretty straightforward, right? We are grabbing the humidity and temperature from the sensor once in every 800 milliseconds, right? Close to a second. So that is the code. Now I'm going to push this into my microcontroller, right? If everything goes well, it says uploading done. And there is no visual element to it, right? How do I know if my code is working and everything is correct? So I'm going to bring up this serial monitor, and you will see some values getting printed there, okay? And those values, 49.9 and 24.8. The first one is the humidity percentage in this room. It's pretty humid, right? That's what it conveys. And this is the temperature. Because of the lights and all of that, we are close to 25 degrees Celsius. We'll leave this as it is. Now what I want to do is grab it from my local machine, stream it to Azure, and feed that into my HD Insight for long-term historical trending, right? And monitor it in real time. That's what we are going to achieve. But the first thing is I need to bring up the code that is responsible for streaming it to Azure. So okay, don't get overwhelmed. This is pretty straightforward. If you are familiar with Python, you will understand. So I'm using the DocumentDB SDK for Python, right? So I'm actually setting up some imports, and then it's very straightforward. I'm actually creating or using a database called AZIoT and creating a collection called weather, and I'm reading from the serial port, right? All this is the initialization code. The most interesting aspect is this. I'm reading from my serial port at the baud rate of 9600. You still remember the baud rate and RS-232 communication, right? So I'm using that. And then I'm going to split my CSV string, comma separated string, and do some basic validation. I want to skip the missing entries. Sometimes you may not get accurate data. And then populate this entire thing into an array, right? So I'm generating a random ID, a GUID. City is Pune. By the way, I actually wanted to hook up a GPS sensor, grab the lat long, and feed that. But again, too much of complexity. So I just hard-coded Pune here. Then humidity and temperature, date, time, and I'm going to persist it into DocumentDB. Pretty straightforward, right? So instead of reading from something else, you're reading it from a serial port. And our Arduino is doing its job by feeding to the serial port, okay? So let's go ahead and run this code. So it's going to take a little while to initialize, but once it starts picking up, it basically reads the serial port and adds one entry at a time. So what I have done meanwhile is I have launched a VM on Azure, which is going to be my analytics front end. Okay. So I'm going to launch that front end. It's again written in Python. I don't know why I chose Python, but I became much more Python savvy than Node for some reason. So I'm going to launch a very simple program that's going to listen on port 80 and acts as a web server. Okay. So we have terrible connectivity here. So this is not streaming. That means I'm losing the connectivity and I'm not able to connect to my VM. So both are not good signs. Okay. Okay. So sudo Python dashboard. Okay. So I have a very small Python program that listens on port 80 and acts as my dashboard. Okay. Let's see. Oops. It's running, it's already running. Okay, so I will leave that as it is. But this guy hasn't started streaming. But while this is happening, let me bring up the browser. So I have Azure IoT.cloudapp.net, and when I hit this, you will see a pretty rudimentary table. I'm not a great UI guy, so forgive me for the user experience here, but I have been running this for a while. So you'll notice there are a lot of records, and the last entry was at 11:54 today morning. Okay, our code hasn't really started streaming, but hopefully it will pick up. Let me try it one more time. If this works, I am extremely thankful to the demo gods, because this is the crux of it, right? Okay, while this is picking up, what I have done is this is for our historical data. This is going to document DB. Then I use data factory and populate HD inside HBase eventually. But how about interactively streaming, right? So what I have done is on the same dashboard, I have a REST endpoint that gives me the latest record, right? At 11:54, that's the last record that my sensor has streamed. Okay? So if our sensor is now streaming, every time you refresh, you'll actually see the latest record showing up here. This is what we are going to use to monitor in real time. So what I am going to do is to show you something pretty cool. This is an open source dashboard called Freeboard. You can go to freeboard.io and take a look at it. So what this does is it can add any data source and instantly help you visualize. So I'm going to add a data type. Okay, I'm going to add JSON, and the name of this is going to be weather. Okay, URL is, because it's running on the same URI, I will just give the endpoint as /latest. Okay, and refresh every 5 seconds. Method is get. That's all I need. I'm going to save this as my data source. It picked up, right? So it is now, it just got the latest record. Now I'm going to add a pane. So I'm going to add a gauge, right, that looks like a meter. So let me call this temperature. Okay, value is I'm going to pick up from my JSON collection. So weather of 0, because there is only one record, I'll grab. So if you notice, there is document DB record here. City, attachments, temperature, RID, ID, time, date. We don't need all of that. We just need the temperature. So I'm going to quickly grab that. The unit is going to be Celsius, right? Minimum is 0, maximum is 100, and we're going to save this. And now you have an instant dashboard for the temperature. Okay, let's go ahead and also add another pane, and this time we'll track humidity. So again, let's call this humidity value is percentage, units, value is the data source, right? So it's going to come from this data source, unit is, it's a percentage, save this, okay? Now this is, looks like our sensor is working because, yeah, there we go, perfect. Ah, okay, but I think it is. So now, this is actually a real-time dashboard of the weather information in this room, right? So, cool, thanks. The beauty is we pretty much built it from the ground up. We picked up the microcontroller, added a shield to it, put the sensor, wrote code, streamed it to Azure for historical trend, and we're also visualizing it in real time, okay? So let me see if, okay. So now, what I'm going to do is to influence this sensor, okay? I'm going to hold it tight, and that will increase the humidity. So you will see that this humidity gauge going up, and it will turn red if our sensor is doing its job, right? But normally sensors are pretty accurate. Okay, there's something wrong with my, so occasionally I have issues with the serial port, in which case I have to kind of unplug, plug, and reboot my microcontroller, but let's give it one more shot. Okay, looks like, but you got an idea, right? It's pretty straightforward. I mean, it can't get simpler than this. So we have now gone ahead and built a dashboard as well. So let me give you some more inputs and wrap this session. So this is what we have done. Can we okay? So temperature sensor to loT to Python Azure SDK document DB, and then we have a freeboard open source dashboarding, right? So this is again a very oversimplified version of IoT. In real time, when you are talking about healthcare, manufacturing, automobile, there are a lot of devices. There are devices, I'll give you an example. In home automation, you can pretty much replace your switchboard in every room with a microcontroller. That microcontroller will act as the hub for that room. It will have all the sensors. You can have variety of sensors, air quality, even LPG gas leak, right? The lighting condition, of course humidity, temperature, and all of that. So it will keep grabbing those values. And it also can operate switches, right? So in every room you will deploy an Arduino equivalent. But every room is generating so much of sensor data every second. And the format is something like, room ID, sensor ID, value. But all of that need not go to cloud at the same time. That is a lot of redundant data. And you may have to normalize. For example, when I am capturing the lat long, before I save it to the cloud database, I want to geocode my lat long to actual location. And it is not very ideal to do it on the cloud because it's very expensive. Bandwidth is very expensive. So once you have the devices, the second layer is aggregation. So all the microcontrollers will talk to a slightly more powerful aggregator, which is called the gateway, right? The gateway's job is to act as an aggregator, as a consolidation point, and it will kind of scrub the data, cleanses the data, and perform some ETL, calls third-party API, and makes some sense out of this data, and then streams it to the cloud, right? So that is the gateway. Then comes in ingestion. Ingestion is where you will persist to a DynamoDB or a document DB or any of that, but the pipe that actually takes your data is the ingestion and pre-ingestion. So in Azure world, this is done through event hubs, right? So event hubs will take a lot of rapid sensor data that is ingested in real time, and then it goes through a lot of stages, and finally it hits the storage, right? And in our case, that storage was document DB, but you could pretty much save it to any source. It can go to HBase or HD Insight. It can even go to SQL Server if it makes sense, right? And then you will perform logic and analytics on top of it. For example, a batch process. There are very tiny, very inexpensive sensors to measure the current that is consumed by an electric device. If you put that sensor between your TV and the electric board and stream the data, after 1 month, you can actually know which is the most power-hungry device in your house, right? That is where you'll apply logic and analytics. This is where you'll actually apply a lot of transformation and a lot of very high-end analytics, and then user experience. Those nice-looking charts, Power BI, integrating that with Excel, SharePoint, all of that comes in user experience. So this is a multi-tiered architecture. In a lot of ways, this is like an n-tier architecture. The only thing is, earlier we used to have data entry operators keying in. Now we have sensors streaming the data, but that is the first tier. The second tier is aggregation. The third tier is the ingestion. The fourth tier is the logic and analytics. And the fifth tier is what you see as the great-looking dashboard, right? And Microsoft has a pretty solid story around it. This is, I presented in a circular form, and this is Microsoft's way of telling you how it is done. And this is Azure Stream Analytics, just one example, right? Not just Microsoft. Google is doing it. Google has a technology called Google Cloud PubSub and Google Cloud Data Flow. Amazon has this. Amazon has Amazon Kinesis, Cognito, and Lambda, right? And of course, DynamoDB. But this is like a reference architecture irrespective of the cloud that you're going to use. And this is how industrial IoT will be eventually done, right? Cool. So I think I am on time. I took exactly 60 minutes. And if you like my session, please use this QR code and rate my session. That's very valuable. Yes. Let me start here. Yeah.
Hey, maybe it's a very silly question, but from maybe Congress chaos conference that we heard about it, it's an international organization. Now, we are using sensors a lot. You see that there are a lot of sensors that we are planning to put forward around us, and they would be definitely emitting something. We know about what it will emit. So, don't you think this will be a problem for us in the long run? In future, because we have too many sensors, we already having too many sensors which are there. We have the network for internet, like for mobiles, we have some. So
see, that is the flip side. See, I know where you're coming from. So basically, your question is security, confidentiality, privacy.
No, not privacy, but it's going to affect us, right?
I mean, in terms of radiation, right? No, nothing can be more radiating than your Galaxy S4. Or iPhone.
Exactly my point. But
so,
see, the number of devices that are coming up near to us.
No,
the number of.
I don't think. See, what we don't realize is we are living in the middle of lot of wave propagation, radiation, and if at all, as a human, we can see that wavelength. We don't have a place to live. It's that occupied. The spectrum is so much occupied that we are already living in the mess of wavelength spectrum and.
Exactly.
And so that is not going to change, right? But that's not going to be of a huge concern. It's not going to affect your health or your mental conditions, or it's not going to create any problem because we have been living with that for, I think, 3 decades now, at least, right? When television started, this was a concern. Everyone said radio frequency will be responsible for cancer, right? Then when Vodafone and Airtel started cell towers, everyone fought. But nothing happened. I mean,
there are still instances that have been there.
There are, but it is not proven. There is absolutely no scientific proof that GSM radiation is responsible for, lot of health hazard. There is nothing like that. It's unproven. Similarly, when you switch on an electronic gadget at home, it is emitting a lot of radiation. Exactly. You don't know what it is. Just because you can't see with the naked eye doesn't mean we are safe. And this spectrum that we are talking about, for example, there is a technology called 6LoWPAN, which is IPv6 in a low personal area network. That is not going to, that operates at a very different frequency. It's not going to impact. Then there is a new protocol called ZigBee, which is meant for sensors to talk to the aggregator. That is at a very different level. And if your home Wi-Fi is safe, then all these network frequencies are safe. Right?
Okay.
Yes, next question. I
Right.
will come to it. Yes.
Can we shift those listeners to the device itself on any shield or any other thing?
Yes.
So that will be much useful in that
Of course.
case.
So the question is, do I need a powerful Mac or a PC
Yes.
to do this? No, you don't need.
Yes.
For example, I would have ideally carried a Raspberry Pi, which would effectively replace my Mac, right? And the Raspberry Pi acts as an IoT gateway. In fact, my next demo is that, right? And
So can it be one device itself, shield, another shield over it?
no, it's not a shield. So basically, the
Raspberry Pi
architecture.
I understand, but can it be this device itself is directly talking to net?
Let me clarify that. So every room has bunch of sensors and Arduinos, and for your entire home there is only one Raspberry Pi. Okay, and the communication between Arduino and Raspberry Pi is using a very low energy, either BLE, Bluetooth Low Energy, or a Zigbee serial communication. For example, just to give you a sense how power efficient it is, if you put a flat battery that normally runs your watches, the Zigbee chip can run for 1 full year. You don't need to touch that. So you can assemble that in a tiny soap box, plug that cell in that, and just drop it in a corner. And it will keep communicating with Raspberry Pi over this low-level network.
So is there any shield for Zigbee for this?
There are lots. It's an overwhelming thing, right? I'm actually spending some time with Intel Edison, BeagleBone Black, Spark, Little Bits. It's an ocean. There are a lot of things. Next question. Last but one.
There's a thing called graphene. Graphene is a layer of is a single layer of graphite.
Mm-hmm.
And, it's a non-metallic, but it's used for communication.
Mm-hmm.
There are applications that run on it currently.
I'm not too sure. I'm not too familiar. This is an area that is vast, and it goes deep into computer science and networking and communications. What I am currently looking at is just the very superficial, the tip of the iceberg. So I don't know about that.
Janaki, one last question. See, we have heavily invested as a developer. I come from a development background, being in with Microsoft for 9 years, right? And I see this is more for an embedded programmers, electronic engineers, right? Should we invest? Because when I Googled as well as searched about IoT, there are a lot of devices on eBay, right? And this looks more on a fun part, less of a serious business part for individuals like us, right? Because I come from engineering background, we see electronic and ECE people and IT people. IT people more of software developers who code ASP.NET and Java, right. And ECE and EEE people looked as embedded programmers, right? So is it more for them to grab and understand REST endpoints and cloud and do it quickly, rather than ASP.NET developers and Java developers digging into it?
It's a very different thing. See, in 97, doing DHTML and HTML was kid stuff. Pretty cool UI, but you know what? I am a COBOL Kicks developer. I get paid for doing it. This is meant for kids. And today, CSS and jQuery and Angular and JavaScript is like our bread and butter. Okay? So it's a matter of time before they become bread and butter. The moment Infosys closes a huge deal with Ford to implement industrial IoT and connect every car, it just becomes a multi-million-dollar business, right? So if your question is there money in it? Is it going to define my career? Absolutely. 12 to 18 months from now, this will become your daily activity, right? That's one. Second thing is, if you are talking about cloud and all of that, remember IoT is an intersection of three. I call that the perfect storm, right? The perfect storm of embedded programming and electronics. The other one is your fundamental distributed computing and cloud and web, right? And data science. When you put all the three together, you have a solid IoT story platform. But it doesn't mean every IoT professional will be equally good in these three bubbles, right? There will be data scientists who will not care what is a microcontroller and what is a sensor. They only focus on predictive analysis and machine learning and analytics. Then there are cloud engineers who will define stateless REST endpoints and define highly scalable streams and figure out Apache Storm, Spark, Kafka. That is a very different thing. And then you have electronic engineers who don't care where the data goes. They will try to convert this form factor into tiny coin-sized ones and make them more energy efficient. When all these three professionals work together, you actually have a solid IoT team. Right? That's how our three-tier architecture also works. You have front-end developers, you have application platform developers, you have database engineers and database developers. Nothing changes. It's the same thing. And you can't be all by yourself. You need to pick your specialization. Right? One last question. I'm confused. Too many. Right. Right. There is definitely. See, for example, there is a board which I bought called NetDuino. It's a .NET version of Arduino. You can use Visual Studio to program this. You can write C#. Absolutely. The .NET with core CLR coming up and everything becoming open source and the footprint of CLR getting shrunk, that's the future. And Windows 10 already runs on Raspberry Pi 2. And it might even run on BeagleBone and other platforms. So definitely if Microsoft has to stay relevant, they have to cut it down to a level of running it on microcontrollers. That's going to happen.